All right. Well, welcome everyone back to the Anarchist Project. And tonight we get to finally start to wrap up this project that we were working on forever, the Midi controller. Because now we have parts. And most importantly, the last one we were waiting on, we have circuit boards. So, I held it upside down. This should be awesome. They came out really nice. I like this blue color. And it's hard to tell even in the pictures or anything, but the text on the top there is actually chrome, while all the other text is white. That's because all the other text is ink, but the chrome text I actually put in the wires in the electrical layer. I just drew that with metal, and they went through with their acid etching process, and there you go. We got chrome lettering. So that came out really well, and I think I'm going to do that more in the future because it looks really awesome. So hopefully we can get all this done tonight and sort everything and start building this. I don't have a way to modify the shells yet, the enclosures, but they do look good. So, but we can mount the circuit boards in the base and then work on that part later, and at least verify that everything functions electrically and that we can start moving around and using it. It just won't look, aesthetically very good, but we'll go from there. So feel free to ask me whatever, or suggest future project ideas, and I'm just going to get to work on this. There is so much stuff around here, and it's just a huge mess. That's okay. It always happens when you're finally building a project. You just have so many components, and you got to start putting everything together. So we do need to use some of the existing switches that we had before. So I need to pull these wires off and get the solder off this one as best as I can. So we'll start with that. I'm going to go ahead and turn the music back on, though. I have something to listen to. And we'll get this thing fired up. All right. And hopefully I don't set anything on fire. Give me just a second. I'm gonna do something real quick. But in the meantime, how's everyone's Tuesday going? All right, sort it out. Yeah, let's get this fired up. I don't know, 740 degrees sounds good. And as usual, I will try not to burn myself or set anything on fire. Hey Terrence, glad to hear it's going well. I forget, this is not the best iron in the world. It takes a little while to heat up. It's a pretty good one, don't get me wrong. It has been a workhorse on this channel, that's for sure. All right, let's see if we can get this going. There we go. Try not to burn the plastic here too. There we go. Just toss those to the side. All right, we got all our buttons back. And then I need to get this thing cleaned up. I just realized I gotta be really careful where I hold this. There we go. Hopefully I can clean this up well enough that it's easy to put on the board. Yeah, it should work. This is going to be the moment of truth, too. I'm terrified that, we're going to put this together and it's not going to work. And then that'll be set. That's always the danger when you're buying custom-made circuit boards. It's kind of a really permanent solution. And it's difficult to adjust later. There are certain things you can do, certain techniques in design and things to make it fault-proof. But, if you mess up in the design, that you can change things on the fly. But you can't predict everything. All right, that looks good. I think we need to start putting. We should put the teensy on first, and then go from there. So teensy goes on the other side. Plug facing up, and you can see it drops in nicely. The pins come through the other side. I probably can't see that at all. So we'll need to get like 1 or 2 soldered on, and then I'll be able to just hang it here and just work my way through all the pins. So we'll start with that. Okay. You know what? I don't know if I grabbed any solder. I thought oh, it's behind my monitor here. Just a sec. All right. Probably got to go through quite a lot of this with all these pins we got to solder and everything. All right, let's get started. There we go. I wish I had a second camera so I could do a close-up so y'all could see what was going on. Probably be way more interesting to watch. Alright. I'm just going to get all these pins and try to breathe in as little of the fumes as I possibly can. The smoke. That's smoke now is good though, or is okay. Smoke later is bad when we fire it up. Did I put that on the right way? I did. Okay. I had a moment there. There we go. All right, one row of pins is done. I'm debating whether or not I should build one fully and then try and turn it on and see if it works, or if I should just go ahead and build both. If it doesn't work, it's not like I really have a backup plan anyway, so I don't know. Yeah, I'll probably just build one fully and turn it on and see if it works. And then build the other. There we go. All right. Trying to scratch it too much. So our teensy is on. First step good. So now then, oh, excuse me, throat's dry today. All right, so now the next part is see if these slide switches drop in or if I got the board the wrong size. Oh, it drops in. Perfect. And it's got some features here to make sure you put it in the right way. So sweet. I like it when things don't like when things work on the first try. All right. I'm going to have to hold these in the same way I did the other one. Do it upside down. Please stay. There we go. Anybody see the Electron launch? Something happened and the second stage didn't ignite. And they lost the rocket and the satellite. That was really unfortunate. All right, first slider's in. All right, let's see. I apparently can't do this upside down very well. There we go. All right, let's get this next one on. Then I'll put the resistors on. I have the CAD file pulled up too so that I can remember where everything goes in the hardware assembly. Sweet. Also, let me know if the music is too loud or if I'm too quiet or something. I know I have the mic set up kind of a weird way right now, so. Okay. There we go. All right, that looks good. This is exciting. Seeing it all come together. All right, one more. Then I'll pull it up, we can inspect it. Excellent. Hopefully this all lines up well height-wise too. We did a lot of calculations regarding the height and the standoffs and everything, but see what actually happens when we try it. Ooh, this iron's been on for a while. It's getting hot. Let that cool off for a sec. All right. So, I think we got this. All right, check that out. Got all our sliders on there. And now we have a semi-functioning MIDI controller. If we plug it in now, we should have enough to actually like work the sliders. I'm gonna go ahead and put the resistors in though. Thanks. I commend you, Terrence, as the sole viewer right now. Sticking it out. All right, these are 220 ohm resistors. This always happens to me. I haven't figured out a rhyme or reason to stream viewership yet. It seems that the streams that I think will be the most exciting are actually not, and or vice versa. I'm like, well, this will be a really boring kind of stream. I don't think anyone's going to watch this, and I'll set a record for viewers or something. It's just funny. Shows that I'm really bad at predicting it. All right, I'm gonna have to cut the ends off of these because they're gonna stick way through. All right, 4 resistors for 4 buttons. This is solely so we don't get a surge and mess up the pins on the micro. It also kind of helps with the debounce a little bit. Just a little bit. You really want bigger resistors if you want a serious debounce, but all right, let's get these lined up. I think for so the other project that I'm working on, the lightsaber, I think I'm gonna make the switch to surface mount stuff and not through hole. I'm gonna get big surface mount components like 0805s. Those are fairly sizable. And I think that'll make it okay. But I will, at least then I won't need a microscope to do it. I've done a lot of 0402s, which are like a quarter the size of that by hand. And you need a microscope to do it, and you just can't shake at all, and it's so hard. All right, moving along. Come on. There we go. I might be getting some cold joints. There we go. Sometimes it's tricky. I got the big tip on this iron so I can heat up. Through-hole components tend to require a lot of heat. Do my best here, but we'll see. I might flip it over and solder the other side too, just to be safe. Here we go. All right. That was way easier to get in those switches. Yeah, let me touch it up on this side. And then I can cut the ends off. Hopefully I have something to do that. I have this thing, but it's not going to be very easy. We'll come back to that. Go. All right. I think that works. All right, so it's going to be impossible for you to see, but there's resistors in there now too. They're kind of green. Now I'll cut off as much of this, the lead on this as I can. I'll have to come back later if I can get some better wire clippers. Well, they can break off pretty easily. That's interesting. Oh, good. I'm glad you're able to see them. I should probably get a better camera too, if I can ever. There we go. If I just move them back and forth, these leads are breaking off right at the base, so that's good. There it goes. All right. Not the most glamorous solution, but it does work. There we go. All right, solid. We have our completely built circuit board. All 3 sliders. Good to go. I want to try it. I want to plug it in and see what we can come up with. So, start up our music app here. And then I've got the code open, window open too. I need to update these bounties. Hang on, let me fix this real quick. Actually, I'll leave that one up. My computer's running slow. I think Windows did an update recently. There it is. There we go. I wanted to do that for a little while. All right, back to it. Authorize later. Okay, so, oh, you know what I need to do also? So I plugged in a USB-C to my computer to work with, but this uses a USB micro, so I got the micro to USB-C converter. We'll have to see how this does, though. It's part of the reason why I want to do this, too. This electrically tests pretty much everything. All right. And then if this looks good, then we'll start mounting it in there just to get an idea of how that looks, too. All right. I can already tell you, though, this is going to be very tight when it's inside. Probably have to be squeezing everything in. But I think it'll work. All right. Let's plug this part in. I don't feel it get hot or anything. It's not exploded yet, so that's a great start. Let's see if we can upload something to it. This one is probably already programmed, but I want to just double check. So we'll verify this again and try and program it. Compiling. Fast when it's catching a bug, but slow when everything's working and you do need it to go fast. Or something like that. I don't know. Let's take a recommendation from the chat. What should I have for dinner tonight? Wow, this is taking a while to compile. There we go. Okay. It's going to work on the first... Oh, it's uploading, so that means communication's going. That's good. Great start. Hot chicken. Ooh. That sounds really good. I really wish. Oh, I gotta select a different teensy port. Interesting. Okay, it's uploaded. The core is getting a little warm, the CPU. But I think it gets warm naturally because it's running so fast. All right, let's see here. Did I previously set any of these? Oh. Oh, that's a good sign right there. I don't know if you can see this on your screen, but in the up here at the very top, you can see this yellow blinking. There, right there. That's happening as I move these switches, so that means there's communication that it's recognizing. Oh, that's so cool. Okay. So we need to assign values to stuff, and I don't remember how to do that. All right, I'm just going to pick some of these at random. Okay. I think that means that one is set. There it is. There it goes. Okay, cool. And I think we got our orientation right too, because you can see, so I'm going to move this at a constant speed, and you're going to see that on the low end, it moves really slow. And then as it goes up higher, it just takes off. So there's a taper to it, which I think means we got that correct. We can always write a function to modify that if we need to. There we go. All right, so I set a couple more. There we go. So you can see that one over there is moving up and down. And then that one there is moving up and down. And that one there is moving up and down. Oh, that's so cool. I'm so happy it works. I'm so happy I didn't buy these circuit boards and they failed. Okay. So we got to test the buttons, I guess. But I would do I mount it first? I think no. I'm going to have to excuse me. I'm going to have to resolder the buttons at some point because in order to get them through like a hole, they can't be attached to the board. I probably should have gotten some sort of like crimp contacts for them or something. That's okay. There wasn't a lot of space though, so. But I think for right now, in order to test the full like electrical functionality of the board, I do need to solder some buttons to it. So let's do that. Good thing I have wire. Oh, I'm so happy those sliders worked though. If nothing else, that's like a major step forward. All right, we're just gonna go classic, black for one side and red for the other. I agree, it's really cool. That makes me so happy right now. All right, I'm gonna turn this back to the, oh, and I messed up that current roll. That's okay. Production quality of the stream is noticeably lower today than it usually is. Because I'm trying to figure out how to do everything. I don't need the wires to be that long. Honestly. Because the case isn't that big, so yeah, we'll go with this. for the lightsaber, I plan to up my build quality a little bit and, you know, heat shrink wires together and maybe even use cables with connectors on the end of them. And everything I can to make it just a little better. That hot chicken idea sounds really good. I gotta decide if I'm actually gonna go out and get some chicken or if I just eat leftover pizza tonight. All right. Got our red wires. Now we need black wires. Everyone see that crazy plan that SpaceX filed with the FCC for orbital Starship? That's gonna be wild. And they intend to do it soon, and I still haven't seen a Super Heavy leave the factory yet, so I'm curious if they really will get that right on the first try. Okay. I gotta strip all these wires. Not the most exciting part of the stream, but you know. There's always that element of this kind of stuff that has to be done when you're testing out prototypes and everything. Can't just have a factory build it for one unit. You have to kind of put a bunch of parts together yourself. Oh man, I'm so happy that works though. Just to have it turn on and plug into interface with the software and not explode. That's my favorite part, is it didn't catch on fire. Always makes for a better experience, more satisfactory result. Okay. So I'm thinking I'm going to solder the wires coming from underneath. That way when you open the device up, it's not like a bunch of wires over top. And I guess I'm a little worried if they're on top too, they get in the way of the switches and stuff. So underneath. Now this will be a little, I don't know if I made these holes big enough. I think I did. But it's still going to be a little tricky. You know what? I probably should unplug this and not have like current running through it while I'm doing this part. Okay. Too many strands. Let's see what I can do here. There we go. Sweet. All right, I should be able to hang all these in here. Doesn't matter which side I put the red or the black wire on, thankfully. All right. Let's get going here. Get all these in place. Let that heat up for a second. Man, Terrence, you got me thinking about chicken so much now. I'm so hungry. All right. Should be heat up enough. Go. This is going to require quite a lot of heat. There we go. It's really good. Like I said, you got me wanting it. All right, I think this one came out a little bit. Yep, it did. Let me heat this up and push it back in. All right, now the black wires. I'll turn this one sideways. Well, it's not going to make it easier for me to solder though. Oops. A couple strands come loose there. Doing my best. Uh-oh. Lost one. Might have to go ahead and solder some of these in place as I go. Actually, you know what? I can actually bend them in place a little bit. One more. We're so close to having a fully working one. All right, let me get these soldered into place. All right, there we go. Let me see. Quality of the work here. Some things need to be touched up. Make sure you get these wires all the way in. Don't want as little exposed metal as I can. Keep anything from shorting. Okay, cool. So we got all the wires on there now, which makes it look extra ridiculous and awesome. All right. Now I gotta get these put on. Try and clean some of the solder off this one. So when you're saying it's really good, do you mean that you had chicken for dinner? Hot chicken? I'll have to come back to that one. I didn't realize how hard it was going to be to solder these buttons on. There we go. All right, we'll get these two soldered on. Pretty soon we're gonna have all these buttons. All right, come on with a better solution here. It's moved around too much. Let's see. There we go. All right, I think that works. Got a connection. Ah, Parmesan fries. It's a heavy meal, that one. All right, that looks good. Probably break off in a little bit. But that's okay. We gotta start. All right, next one. Come on. There we go. I wish I had smaller gauge wires. I lost it. I may not be able to have time to build 2 tonight. The rate this is going. All right, come on. Stay in place. All right, perfect. That one should stay. Let me get the other one. There we go. All right, next button done. It's 2 down. 2 more to go. All right. Apologies if you can hear the upstairs neighbors. They've decided to go on their usual stampede. All right. This one's set up. Sweet. There we go. Alright, there's another one in. Looks like I got some contacts that are shorting here. Don't want that. Try and get some solder on those to make sure that doesn't come loose. Oop, I can smell burning rubber. The insulation. Whoops. All right, one more. I didn't think this would be the most tedious part, but I'm just gonna get this one soldered in place. All right, one more wire. And then we'll be able to do a test. I'll see if I can activate a bunch of stuff in Ableton here. There we go. This last two I've had trouble with some wires shorting. So some strands of the wires shorting. So let me get these out of the way and get some solder on them. Just to be safe. Oh man, this soldering iron's getting so hot. You just give that a break. All right, now we got all 4 of our buttons on there. So now I'm gonna do this test again. Let's plug it in and see what we can do. But I'll show you real quick. You can see a close up. Everything's soldered on there, board underneath, switches, sliders on top. So we're doing good. All right, let's plug in our all right, perfect. So here you can see I'm sliding this knob up, and we can see our dial there, right here. And then this one. And then this one over here. All right, now I need some buttons to try out. I need to somehow organize these, so I'm always hitting the same one. Here, I'm actually going to set this down. Hopefully I don't snap any of these wires by bending them. I got stranded cores, not solid cores, but we'll see. Could always happen. Get this stuff out of the way. All right. So if I hit it now, does it do anything? I can't remember if I had them signed. I don't think so. All right, we're going to assign them. Play is this first one. Stop is going to be this next one. Record is this next one. And then I need to pick a random thing that can be a button. I guess this one right here. Okay. If I turn that off. All right, so double check that our sliders still work. First slider, second slider, third slider, and then hit play. There it is. Hit stop. Yep, that did it. It doesn't flash, but it did stop. When I hit it, it stops. You can see the numbers are 1, 3, 3, and then if I hit it again, it actually resets. Record. And stop. And what's this last one? There it goes. Selects that track. So I think everything works. We did it. And I realize our current goal is messed up here, so I was going to change this. But it appears that the MIDI controller is fully functioning. So that is a great start. All right, there we go. All right, so now that that's looking good, we should take the time to validate our hardware and mount it in this shell. You know, I didn't even bother to check beforehand if we had lined up the measurements right on the holes and everything, so we'll find out. And then I have our FreeCAD model pulled up here, so I can see where all the washers and standoffs and everything go, and I can see what standoffs go where. 10, A424, 925, and the 424. I guess I should do the other side first. Well, let's double check that it's going to line up and fit correctly. I'll unplug this. Oh, it looks good. It's hard to see. I think it looks good. It might be slightly off. Not an amount that matters, but plastic has a slight variation to it in its tolerance. You'd be surprised. Injected plastics have quite a high tolerance, actually, for how much they can vary, so... That's a good start. All right. So we need to sort out which standoffs go where. Obviously the taller round ones go there. The hex ones, here they are. Okay. Whoops, I am so sorry. Just caught my microphone there. Hopefully that didn't make too much noise. How many washers? Just one. All right, let me find the washer. What's that? Machine screws. Flat washers. 100 of them, because, you know, why not? Because they come in packs of 100. Alright, hopefully I guessed on the sizing right here, too. It looks like I did. It looks like we have enough room on our circuit board. Yep, that looks right. Oh, wow, that looks awesome. Okay, cool. Alright, bear with me here. I know it's a mess. I'm also gonna... Here, I'll turn on the webcam screen so you can see what's going on. That should be enough. I know one of the things we were worried about was how far through this thing, like if the threaded part on this standoff was going to be enough. Probably should have gotten some like lock washers or something just to be safe, but I think this will work. Oh yeah, perfect. Plenty of grip. Oh, that looks so cool. All right, let's get another one. Oh, I forgot the washer. No. Whew. Almost got it stuck. All right. All right, so that part looks good. Now hopefully these other ones that I got are the right size. I didn't mess that part up. I'm going to go ahead and plug this piece in because I won't be able to reach under there very easily afterwards. Oh, that looks like it's going to have a surprising amount of room in there too. Well, maybe. It's going to be tight, that's for sure. To pull this out and rework it in at some point, but... Alright, where are they? Small standoffs. Here they are. And where do we put? We put one washer underneath. And then we get the washers. I love the mess of stuff here. Okay, where's that other box of screws? There it is. I know I'm missing something. These are pretty good size screws, so should help us. I don't think these are threaded standoffs. Nope. Okay, good. Eesh. I might not have gotten long enough screws. We'll see how that does. I also just realized that the way this is designed, so you know, hindsight's 2020. You always see all the things you did wrong later. It's really actually really hard to attach. I probably should have gotten a threaded standoff. All right, work with me here. The wires are actually making this really hard to land in here, so... Okay, I think I'm on track. Yep, that bites. Let's make sure this other one's going into the right spot. Yep. All right. I don't want to put them in too tight, because they are just machine screws into plastic. I wish I could have gotten something better, but I might need to get bigger screws. We'll see how well this holds up. Worst case scenario, well, no, that won't work. I was thinking I could just flip around the bottom if I tore them out, but I really don't think I could do that. So, all right, so there's a little bit of space there, but not much. Our tolerance is pretty tight, so, but it's easy enough to move these back and forth. So, okay, one more test, since that part looks good. I got some rubber stoppers to put on the bottom here as feet to kind of hold it in place so it wouldn't slide around when using it. So now it's time to see if that plan actually has any chance of working. More boards. This is that kind of plastic that things don't stick to very well also, so let's see how well these work. I figure of the two of these that I'm going to build, I'll give the one that looks worse to Bitomy, and I'll keep the better one for myself. All right, there we go. Oh, yeah. That grips the table great. Perfect. How does this look height-wise now? That's another thing that I wasn't so sure about. Pretty good, actually. I think this is going to be solid. I wish I had the ability to cut this right now. I'm going to use the rest of the stream to put the other circuit board together, but this is solid, so let me pull up Ableton again. Get that plugged in and see, yep, everything's working. Oh, it feels so good. All right. Cool. Well, there you have it. There's not more I can do tonight, unfortunately. But this is what our device looks like currently. Here, let me make it easier to see. There you go. So these buttons and those sliders, everything mounted in place. We can do a quick comparison here. I know it's not the exact comparison, but if I pull up this screen, oh, other way. There we go. That looks similar, right? We got pretty close. Sweet. All right, I'm going to build the other circuit board since we still have some time. And that way I can be ready to put the other one together. All right, I need a circuit board. Can't believe we got a pack of 5 of these things for like 13 bucks. It used to be like you could get these circuit boards like dirt cheap if you were okay with waiting, 2 months for it to come in. Because it would take forever for them to get it through the process and then like a month to ship it from China. They built these in 4 days and shipped them in 5. Which is, for $13, is insane that you can get a custom circuit board at your front door in like a week. So, and the only reason it took that long to build is because I requested specifically that they do a full electrical test and that their engineers confirmed the production file with me to make sure that everything looked correct, that there wasn't any mistakes. If I had just gotten a green board and done bare minimum stuff, it would have been a few dollars cheaper, and they said they could have built them in a day and then had them out the door. So I just think that's incredible. All right, so for this next one, I don't even have the headers on this teensy yet. This teensy's never been used, so we got to start with that part and put on some headers. Oh no, it broke in the wrong spot. A disaster. Oh, dang it. Well, I don't use that last pin anyway, so I don't think I do. Yeah, it's not even grounded or anything. Alright, that'll be fine. Oh, it's the other side. Yeah, that'll be fine. Whoops. Alright, let's get this up. Thank you, book. Me too. It's been a long time coming. Hopefully I'm hoping the customer will like it. I'm already excited to move on to the next project. To move on to the lightsaber, but I know I really got to finish this out. I still haven't gotten a Dremel yet to cut the slots and everything, so I really need to do that. Otherwise, Thursday's stream is going to be a little awkward. All right, hold still. Is that dogs barking? Sounded like some dogs barking outside. All right. Should be hot now. Come on. There we go. I'm going to go through and get a couple pins on the end so that it's started, and then I'll go back through and do all of them. Just make sure everything lines up. I'm going to have to go through and do the math after this too to see like what the total cost is if you just decided to make this on your own. If you didn't actually want to buy your own MIDI controller, how much would it cost you? The answer is a fair bit, at least, because there are some pretty expensive parts in here. The teensies are 20 bucks each. The circuit boards are, well, you have to go for the minimum, so I guess it'd be like $10. Here, stand up. There we go. The sliders were a couple dollars each. The buttons were a couple dollars each. So that's like 14 more dollars. It's 34 plus 10 is 44. Plus the shells, which is $4. Plus shipping, which was expensive. You know what? Honestly, most of these parts weren't that expensive. It was the shipping that made it cost a lot. I'm going to guess close to 70 if you just went for the bare minimum. But if I made like, I don't know, even if I was making like 10, that price drops dramatically. And then if you're making 100, it becomes pretty dirt cheap. Maybe if it's working in solid, I can do a Kickstarter if people want it. All right, sweet. Got that mounted, so now I need to go through and solder all the pins. Let me do the teensy first. All right. Moving along. I should get one of, they make these little fan things for when you're soldering that suck the smoke away from you. Really need to get one of those. All right, so what I'm going to focus on doing here is getting the teensy on and getting the sliders on and the resistors. I'm not going to worry about the buttons on this one yet. All right. Let's get that side on. Let me just make sure, hold on, a couple of these are soldered in place correct. It's really easy if you're not paying attention to get cold solder joints. Basically what that means is it looks like it's soldered, but there's not actually an electrical connection. All right, now we gotta get the other side. Try and tilt this down a little bit so y'all can see better. It's like 35 pins or 34 pins on each teensy that has to be soldered, so it takes a little while. All right. Oh no. Got a short. Accidentally soldered a couple pins together. Come on. Rats. I don't have any solder wick either. All right, got it. Scary moment there. All right, sweet. Now I need to get the switches in, the sliders in. Right. I think I might have a way to make this a little easier. Maybe. Maybe. There we go. I think that did it. Flip them upside down, solder the other side. Yep, that seemed to help make them stick. There we go. I know I've said it already many times, but it's just like the best feeling in the world to see a project coming together. These moments too are a good time to like look back and go, okay, what could we have done better? Even while building it, you can still think about that stuff, like what would have made it easier to build or look nicer. Or, oh, I didn't realize this part was going to look quite like this. Love to hear anyone's thoughts on what we could have done differently to make it better, if you have any, because that's the kind of stuff that we need to consider in the future, to make sure that like we address, like if it's something that affects build quality or something, or a different change in process, we can start thinking about it now and how it would affect future projects. Okay. That part's in. I'm trying to scratch these boards too much. I think it's inevitable though at some point. All right, now we gotta get the resistors in. then we can fire this one up and program it, see that it works. We saw plenty of these resistors left over too. There we go. Get all these resistors in here. These resistors are way smaller than the outline and the footprint that I gave for them. That was definitely an oversight when I was buying them. So it's just kind of comical. There's this big like outline for them, and then they're really tiny actually. Okay. I'll flip this around and get all these soldered in place, and then we'll break off the leads, and then program this board and show that it's working. Oh, I'm getting tired. Got a cold joint here. Come on. There we go. This iron is getting hot. It's been seeing a lot of use tonight. They make these really nice ones that, like, when you put them down in the thing, they turn off, and then when you pick them up, they turn on and they heat up, like, instantly. Definitely need to look into that as an option. Especially when we're doing big builds, like with, 100 components or something. Like, the heat could get to be a real problem. All right, got them all in. I'm gonna snap these leads off now. I was smart enough to leave them on this time, so this is a little easier. So I wanted to talk about an idea I had for the lightsaber, since we're one of the things we had talked about was adding an accelerometer to it, so that we could like sense movement and make sounds and stuff based on that. And I still think that's a great idea. I think we should do that. I think we should take it up a notch. I was trying to figure out a way without having a sensor in like the blade, that we could figure out, like, if you were dueling with it and a certain spot on the blade got hit, if we could figure out where that spot was and make a ripple effect on the blade, since we're using the neopixels, we can do some really cool lighting effects. So I was trying to think through that, and as far as I've worked out so far, like the torque equation, right? When they talk about pound-feet, is a force times a distance, or Newton meters if you want to work in metric. So basically, if you have the torque of a rotation around a point, then in order to calculate that, you need the distance from the rotation that the force is applied, as well as the amount of force that was applied. With one accelerometer, I don't know if you could tell that. I don't think you could, because there's a certain series of equations where, you get distance, force times distance, and the accelerometer would tell you the force that's being rotated around the point. So then from there you could get basically x times y equals the force, right? Where x is the amount of force being applied on the blade and y is the distance. But with one equation, you can't solve for both of those because there's an infinite number of values that those two could be, and still the equation would still be fine. Check it out, we got the whole thing built. So that's not going to work. But I was wondering, if we add a second accelerometer, does that then give us enough data to basically make two equations? And then with two equations, you can solve for two unknowns, and that gives you effectively a system of equations to solve through. I don't know. I haven't worked that out in my head yet to see if that totally works. But the theory is, if you have two measurement tools, then we can calculate, based on two different measurements, how far away the force was applied, and then we could do some really cool ripple effect from it, which I think would be awesome. So I think I'm going to try and do that, but I don't know if that's going to be the method yet, or if I have to come up with some other method. But just a thought. If anyone had any insight into it, I would be very interested. All right. Now we need to program this. So let me connect the other adapter. Where is it? There it is. The micro to USB-C. And we'll get this thing programmed. Hopefully this teensy works. Be a shame if it just like failed. All right. Probably have to change our port, I think. Hold on. There we go. Device is set up. I guess that is it. Okay. Let's upload and see if this works. I don't know if it's going to recognize this one as a different device or what. It did program, interestingly enough. All right, now it's been programmed as a Midi, so my computer has to re-download the drivers and set it up. And then I don't know if it's got the same ID as the last one. No, nothing's happening. All right, let's see here. Check my notifications, see if it got set up. Setting up Teensy Midi. Hang on. Waiting for the drivers to install. Teensy Midi is set up and ready to go. All right, so it looks like our software here is recognizing it, which it should, so that's good, but it's not controlling anything. So obviously it's still recognizing this as a different device. which is good actually. So what that means is that we could probably plug in both of them, and then you can have 6 sliders and 8 buttons that do different things. So what we're going to do is just click on a bunch more of these things and set this up. All right, so this one, going to do that. Oh, not detecting anything. What about this one? Not good. It is detecting it, the change, but it's not assigning it. That's kind of weird. I wonder why that is. Here, let's try again. Maybe we have to use something else, or we could just do this one again. I didn't miss any parts. It is on here the correct way. Oh, I love troubleshooting. I thought everything was going to go perfectly for this one. All right. I think I have a thing that reads MIDI messages. Maybe we should try that. Just make sure they're coming through. Doesn't look like anything's coming through. I can hear the noise every time I unplug it and plug it back in, so my computer recognizes that that's happening. Input monitor. MIDI devices. Weird. Something's going on that I don't fully understand. Probably something that we solved already. But there's not enough memory available for this task. Quit one or more applications to increase available memory and then try again. Interesting. Any thoughts? Anyone have the solution? I wonder if having 2 devices named Teensy MIDI is like the thing that's really throwing it off. MIDI, optimize, faster, 600 megahertz. Get board info. Let's try this. Native serial port can't obtain info. Interesting. Let's try uploading again. Okay. There's messages coming in. We have the little yellow dot here, so it definitely recognizes that there's something happening. That's so weird, though. What happens if I plug the other one back in? Does everything suddenly start working again? Yep. This one's functioning fine. Let me open up the message viewer again. All the fun stuff. Devices. Not enough memory. Okay. How do I view stuff on this again? Clearly I'm doing something wrong here, so. Input monitor. Nothing. Interesting. It's weird that it works, though. Oh, I wonder if because Ableton's open, that's why the thing is not seeing it. Hold on, let me close this. These will be lost. Yep, I don't care. I think I remember that being a thing. Devices. Okay. Nope, that wasn't it. Dang it. Oh, we're so close. Might have to resolve this later, but I mean, we're pretty far along though. We're able to see it work and everything. Oh, excuse me. It's been a long day at work. But we got one working, and the other is like, I mean, it's working. We just don't know why we there might be a name association thing that's making this hard to work with. Authorize later. Okay, this still works, right? Hold on. Let's see. All right, recognizing communication, but it's not doing anything. So every time I unplug it, I got to reassign things because that's kind of annoying. All right. Oh, I accidentally assigned two of them to this one. All right. And then if I unplug this and plug this one in. Nothing there. Yeah, nothing's coming through. All right, I'll do some research to see if I can figure that out. It may just be something about it having the same name or something. I wonder if I can fix that here. Yeah, it doesn't say. All right. Well, I think that's pretty good progress for tonight, though. It's awesome to see it built and coming together. It's awesome to see everything fit. That was my biggest worry. There's going to be some oversight and something wouldn't fit, and then I'd be stuck. So, thank you all for joining me tonight. This was fun. It was good to see this project come into a close, and I'm really excited for the lightsaber project. Like I said, we're going to really just make that as awesome as possible. So I look forward to hearing your all's thoughts and ideas towards it. And yeah, I will see you all later. Have a good night.